So now we're going to do a thing. It's still with quadratics, okay? That's why it's still section 1-2, because section 1-2 is all about quadratics. This thing is going to be called, oops, let me change my little writing thing up here. Okay. It's going to be called completing, I said it earlier when we were going over the homework, the square. Completing the square. All right. Let me show you something that's super important. Let me get my notes out here so I see where I want to go with this. Let's do this. This is a little lead up to what we're going to do. Okay, I want to show you something. I want to show you a little pattern. We actually did a little bit of this today with a perfect square. I'm going to show you a couple perfect squares, and I want to show you a relationship between these. All right. So if I was to do this, okay, I'm not going to show you all the steps, but if you did this, it's x plus 2 times x plus 2. So you do a little FOIL method, so you would get x squared plus 4x plus 4. Okay? So if you were to do this out, you're going to go x plus 2 times x plus 2, distribute it, or do the FOIL method. This is what you would get. Everybody with me on that? I'm going to do 3 more, okay? And we'll just keep them in order. We'll go x plus 2, x plus 3, x plus 4, x plus 5, okay? So if you multiply this out, what do you think you would get for this? Any ideas? It'd be x squared. It's x plus 3 times x plus 3, right? So you do first, which is x squared, outside and inside. That would be 3x plus 3x, which gives you what? 6x. And then plus the last would give you what? 9. You should start, in the next one, you should start seeing a pattern. I hope. A couple patterns. What about this? If I was to distribute this out, can you do this in your head? This would be x squared plus what? Again, it's outside, inside, so it's 4x plus 4x, which is going to give you 8x, plus the last 2 terms, 16. One more. This is enough to establish a little bit of a pattern here. And again, if you wanted to write it out, if you wanted to put 2x plus 5s next to each other and then do the FOIL method, this is what you would get. I'm just doing this in my head. And hopefully, you should be able to figure this out now. What's this going to be? X squared plus what? 10x. That's right. You're seeing the pattern now, right? Plus 25. Good. You see it? All right, so how do you find the middle term? You add this to itself, right? 2 plus 2, 3 plus 3 is 6, 4 plus 4 is 8, 5 plus 5 is 10. Agreed? How do you find the last term? You multiply them by themselves. All right, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. But I want you to look to see another pattern. I want you to look, let's do this in a different color. I want you to look at this and figure out how we got the middle one from the last one, all right? If you look at the first one, that's not enough to get a pattern, right? One thing is not enough to get a pattern because it looks like it's just the same thing. But is it the same thing from here to here? No. What about from here to here? And we're doing the same math every single time. What did we do to 9 to get to 6? What did we do to 16 to get to 8? What did we do to 25 to get to 10? And we could keep doing this even more times if we wanted to, but this is enough to establish a pattern. What do you think? 2 steps. We did 2 steps. What do you think you did to 9 in order to get a 6? What do you think you did to 16 in order to get an 8? Okay, you didn't just divide it by 2. You divided it by 2. I'm sorry. I lied. You did divide by 2, but you didn't do it first, okay? Because you didn't go 9 divided by 2 is 6, right? But you did something else first. Actually, you know, I went this way. I'm thinking the other. Stupid me. I wish I could. You could have gone this way, but let's go this. This is better. I'm sorry. I should have done it this way. That was dumb of me. All right. What about from here to here? Let's do it that way. You could have gone the other way, but this is a better way to do it. Well, the first step was correct. What you said on the first step, but you don't just divide by 2. because 6 divided by 2 is not 9. 8 divided by 2 is not 16. Okay, but we did something else. Okay, but we're going this way now, okay? I did something to 4. I did 2 things to 4 to get 4. I did 2 things to 6 to get 9. 2 things from 8 to get to 16, from 10 to 25. What is it?
I don't know if it's right.
Well, Gage's first step was right.
You divide it and then don't you multiply?
By? You square it. That's right. You square it. You don't just multiply by 2. That's not going to work. But what you're going to do is you're going to take half of it, and then you're going to square it. Let's see if that works. Would you agree if that works on all 4 of these? We kind of establish a pattern here. Okay. So let's take this. Let's take the 4 divided by 2. What do you get? You get 2. And then if you square it, what do you get? You get 4. So that one works. Let's see if it works for all of them. Take that 6. What are we going to do to it? Divided by 2, which you get what? 3. And then what are you going to do with that 3? Square it, and you get what? Oh. You get 9. Now you take 8. What do you do to it? Divided by 2, which you get 4. And what happens when you square a 4? You get 16. It works every time now, doesn't it? Would you agree? Take the 10. Divided by 2. What do you get? 5. What do you do with that 5? You square it. What do you get? 25. Would you agree? So now, let's do this. This is where it's really cool. This is where we actually complete the square. This is where we're actually completing the square. What if I said x... Oops, I wanted this white. Hold on. Oops. There we go. Okay, what if I said this? What if I said 6x plus 12x plus blank? What's going to be right here in order to make this a perfect square? A 6? A 6 is going to go right here to make this a perfect square? Look at the pattern. Look at the pattern. What do we do to the middle number? What do we do to the middle number? Talk to me. Come on. What did we do to the middle number? We divided by 2. And then, what was the second step? We squared it. So divide this by 2. And you see, you're right. I just wanted you to go one step at a time. Okay, so you took the middle number, divided it by 2. What do you get? 6. How do I find what this number should be in order for it to be a perfect square? I take that 6 and I do what to it? I square it, and then I get 36. So what should be right here then? That should be 36. Now, once I know this is a perfect square, what can I make this? This is going to be what? X plus 6. Everybody follow me? Okay, let's do one more, and then we'll get to the real meat of the problem. What do you think I'm going to do now? What? This is going to be part of what we're going to do to get the answers. You'll see. You'll see. I know you're excited and you want to see what we're going to use this for. But what if I did this? What if I said 18x plus blank? What do I need to put right here in order to make this a perfect square? That's why we call it completing the square. Do you follow me? It's completing the square because I want to find out, what am I going to put here to complete this in order to make it a perfect square, right? I want x plus something. So what am I going to put here in order to make this a perfect square? What do I do to the middle number? I take half of it, right? Divide by 2, and you get 9. What do you do with that 9? You square it, and so that means that goes where? Right here. Everybody see that? Now, what is this perfect square then? X plus what? 9. All right, because you take the square root of this and square root of this. That's a perfect square. I think I've done enough of those for you to see that pattern developing. Do you agree? It is easy, right? It's only part of what we're going to do, though, okay? But it's an important part. It's the completing the square part. That's what this whole lesson is, called completing the square. We just learn how to complete the square. But there's a little bit more to it in order to solve for x on these problems, okay? But that's the heart of it. That's the important part that we need to know how to do. So let's go to an example, and let's figure out how to do it. So x squared plus 5x plus 4 equals 0. Now, if all I did was say solve this, there's an easier way to solve this. There's a very, very easy way to solve this. It's what you just finished doing on that last homework. Okay, you could just do what to this? You could just factor it. But on the next example, you're going to see that not everything can be factored, all right? Or at least not real nice and pretty anyway, okay? So we could have just done this. Don't write this down. Okay, we could have just done this. We could have said x and x. Now this is an easy one. You don't even have to guess and check on this one, do you? You're not going to use 2 and 2. What are you going to use? 4 and 1. Agreed? Pretty easy, right? That's the easy factoring. All right, and then what do? They're both being multiplied, set equal to 0. So let's just do this in our head. What's x going to be? -4, and x is also going to be what? -1. Now that was a real easy way to do it. Would you agree? And if all I did on a quiz or a test, if I just gave you this and I said solve for it, that's the way I would want you to do it. Okay? But I'm going to show you a different way to do it. It's not easier on this problem, I'm telling you right now. So don't look at this at the end and say, why do we have to go through all that? Why couldn't we just factored it? Because there are going to be problems, like in the next example. There will be problems where you will not be able to factor it. Okay? So you can't always factor. You got it? This is why we're going to do completing the square. So here's what we're going to do. I'm going to take this. Is this a perfect square right now? If I take half of this and square it, is that 4? No. So what I'm going to do is I'm going to take this and I'm going to chuck it to the other side. All right? So I'm going to go x squared plus 5x plus, and I'm going to put a blank there. Okay, I'm actually going to put a line for a blank. Equals. Now what did I do with that 4? I just subtracted it. Okay, that's how I got a negative out of it. Everybody with me on that? Okay. Now, here's what we just finished doing. Go ahead.
So say if it's a -4, so would that be a +4 then?
No, it was a +4, so we make it a -4. Oh, if this was a -4, yes, we would add a 4 to both sides. Correct. Okay. Now, this is a little bit harder because it doesn't come out to a nice perfect number. All those other ones that I did, that was an even number right there, wasn't it? All right, now it's not even. It makes it a little bit weirder, but it still will work. So how do I complete the square? How do I figure out what's supposed to go there in order to get a perfect square? What do I do to that middle number? I divide it by 2, and then I do what to it? I square it. Now, 5 divided by 2, that doesn't come out even, does it? But I can still square it. What happens when I square a 5 over 2? What do I get? 25 over 4. That's right. So what goes here? 25 over 4. Everybody see that? We did that over here, didn't we? We took half of it and squared it and got that number. Half and square, got that. Half square, we got that. It's the same thing, except it's just not as pretty because it's an odd number. So I put 5 over 2, took half of it, and squared it, and I put it right there. You with me so far? Let's move this over a little bit. Now, this is an equation, though. Can I just, out of the blue, just add something to one side of an equation? No. But I can do that as long as I do what, though? Add it to the other side. You got it. Everybody see that? As long as I add it to one side, and I just added a 25 over here, 25 over 4 over here, what do you think I'm going to have to do over here? I'm going to have to add a 25 over 4 over here. See, that's basic algebra, isn't it? What I do to one side, I do to the other side. You still with me? All right. Now, again, referring to this stuff over here. Do you remember how we completed the square and it came out to a nice perfect square? Remember that? We're going to do the same exact thing right here. So this, the whole reason that we took half of this and squared it and put it right here is so we can make this into a perfect square. Now it's a perfect square. So now I can factor this and make it a perfect square. What is it? I'm going to put an x. I always take this sign right here. Now what goes here though? And no fractions or no decimals. It's 5 over 2. Because look, how did we get a 9 out of that 81? I took the square root of it. I took the square root of 81 to get that 9. So now, what do I put right here? I take the square root of 25 over 4 and put it there. What is the square root of 25 over 4? It's 5 over 2. Okay? So now we took something really weird and ugly looking. We recognize that it's a perfect square, and we wrote it as a perfect square. But now I got to do some stuff over here. What do I have to do here? Got to add those up. Well, this is over 1. I got to find a common denominator, don't I? Okay, what would the common denominator be? 4. So 1 times 4, negative 4 times 4 is negative what? 16. Would you agree that that's negative 4? And then I got to do the rest of it plus what? 25. All I'm doing is just adding a couple fractions together, finding a common denominator, all that stuff. What's this come out to be? Is that 9? Positive 9 over 4. Agreed? So that goes right here. Now, here's something we did 2 days ago. I think on Wednesday we did this. Or was it yesterday? I can't remember. We did this recently. In the last 2 days we did this. I want to get x by itself. I'm going to solve for x. So we're done the completing the square part. Now we just go back to what we've done before. How do I get rid of this square? Square root. Okay, so that's going to get rid of the square here. But what do I have to do over here? I got to take the square root of this. But I don't just put a positive square root. Remember what we did? Plus or minus square root.
Wait, is this still the same problem?
Yeah, this is all the same problem. We're trying to solve for that x. Remember I told you earlier?
Wait, still?
Remember when I said we could have just factored this and got an answer? Remember we got what, like negative 4 and 1 or something like that? Okay. And I told you this is going to be more involved. And you're like, well, why don't we just do it the first way? Well, we do it this way because there are problems that can't factor. And this is the only option. Well, it's not the only option. It is a option, another option for you. Okay? Let's keep going. We only got a couple minutes. So let's write it a little bit nicer. Equals, let's do this though. It's plus or minus. Now this thing right here, it comes out kind of nice anyway. It's the square root of 9 over the square root of 4. What's the square root of 9? It's 3. What's the square root of 4? It's 2. See what I just did there? I just went from here to here. I just took the square root of it. Keep the plus or minus in front. One more step, basically. One more step to solve for x. I got to get rid of that plus 5 over 2. How do I get rid of a plus 5 over 2? Square it? No, it's just added to it. We just subtract. We subtract a 5 over 2. All right, so that'll cancel out. I'm not going to show it. All right, and then what do I do over here? I got to subtract a 5 over 2 from this. We're almost done. Hang on. Just give me a second. Mr. Rao won't mind. So watch. I got two things here. I got a positive 3 over 2 minus 5 over 2. And then I also have a what? And what else? I got a positive 3 over 2, and I also have a negative 3 over 2. So watch what's going to happen. What's 3 minus 5? Negative 2 over 2, which is negative 1. What's negative 3 minus 8 or 5? It's negative 8 over 2, which is negative 4. Is that the same exact answer as we got before? It is. Okay? It's a different way of getting it, but we still got the same answer. No homework. Okay, I still got another example to give you. So when you come back from your senior work project week,